Hi everyone, this is video 5 for section 2.2 and 2.3. This is the last video for this section. So last time we talked about base B numbers and converting them to base 10. So this time we're going to do the opposite. So we're going to take numbers in base 10 and convert them to a different numeral system. So the first one we're going to look at is 602 in the Babylonian number system. So remember that the Babylonian number system, so this was the one that was base 60. So they had 60 different symbols to denote, or they had 59 different symbols to denote 1 through 59. And we want to denote 602. So since this is a base 60 system, the first thing that we do to convert something with a different base to base 10 is divide. So we take 602, we divide it by 60. So 60 goes into 60 one times. And then we have 2 left over. 60 goes into 0 times. So this is 10 times 60 plus 2 equals 602. So what I think is really helpful is to write this number in expanded form for any base system. So 602 in base 10 is, in base 60 is we have 10 times 60, right, in the 60 place, plus 2 times the ones place. So 10 in the 60 place and 2 in the ones place. So remember that this one, we have two, this is a positional system. So we have different place values. So we have the ones value, the ones place, the 60s place, the 60 squared, 60 cubed, and so on. So the way that we're going to do this is we have 2 different positions. So we have 10 in the 60s place. So we're going to write the symbol for 10. And then we have 2 in the ones place. So this is 10 times 60 plus 2 times 1. So this is 602 in the Babylonian number system. Okay, so the next one is taking 334 to be in the Roman numeral system. So I presume that you're all familiar with Roman numerals. We use these more often in our daily standard life, right? So the one that we use normally is the European numeral system, the digits 0 through 9. But Roman numerals are really common. The way where I see them the most are tally marks, so making tally marks for counting, but also even in just popular culture, right? The Super Bowl every year, they typically denote it with Roman numerals, which Super Bowl it is. So I'm assuming you're a little bit more familiar with this. So remember that the Roman numeral system is an additive system. So that means in order to write 334, we're going to write down symbols that correspond to 334, and we add them all up. So remember that Roman numerals have digits corresponding to the following amounts. So we have something for 1, 5, 10, 50, 100, 500, and 1,000. So I'm going to write this in an expanded form that's a little bit different than what we've talked about before. I want to write 334 as a sum of these things. So 334, so it's in the hundreds. So it has 3 hundreds in it, but it's not quite to 500. So this is going to be 3 times 100. Okay, so that's 300. So now we have 34 left, and 34 has 10s in it, but isn't quite to 50. So we're just going to use the 10s. So there are 3 10s in 34. And then we have 4 left over, so we have 4 1s because it's not quite to 5. So we just write this out, right? So we just combine 3 symbols for 100, 3 symbols for 10, and 4 symbols for 1. So 334 is C, because C corresponds to 100, X, because X corresponds to 10, and then 4 ones. So now at this point, you may be thinking, okay, but when I've seen Roman numerals, we never denote 4 with 3 ones. So with 4 ones. So we don't really denote 4 typically like this, right? I mean, it's accurate, but more often we see 4 as 1 less than 5 is more common. So the Roman numeral system, right, it's positional where we add the things up, but we write it in a way so that this is decreasing, right? So this is decreasing. So we have the largest numeral value, the largest number value assigned to the numeral on the left. So C is 100, X is 10, and then I is 1. So this is decreasing, right? And decreasing means that you add. However, when we increase, like so, when we have the 1 next to the 5, that going this way is increasing. And in that case, we subtract. So instead of doing 1 plus 5, we take 5 and take 1 away. So this 334, another way that we can write it, and the much more standard way, is CCC XXXIV, where we have 300s, right? Let me correct that. We have 300s, and we have 3 10s, and then this down here gives us the 4th. Okay, so just keep in mind that Roman numerals have this subtraction if you increase, instead of going from, right, 1,000 down to 500, down to 100, down to 50, 10, 5, 1. If instead you increase, that denotes a subtraction. So increasing values of our numerals tells us that we do a subtraction. Okay, so now we're going to convert a base 8 number to a base 5 number. So this process is going to be the same as what we just did up here for the Babylonian number, where we divided by the base. So whenever you're converting a number from base 10 to another base, you're always going to divide so that we can find the expanded form in that base. So we have 93 base 8. So we start with doing 93 divided by 8. So 8 goes into 9 one time. We subtract and get 13. 8 goes into 13 one time. We subtract and get 5. So what we really want to pay attention to here are our remainders, because our remainder when we divide the first time is going to give us our 1s. And then this 11 here, well, this 11 can be divided by 8 again. So we're going to keep dividing. So 11 divided by 8, 8 goes into 11 one time, and we have 3 left over. So now this remainder, instead of giving us our 1s, because our 1s place has already been established, this is going to give us our 8s place, our 8 to the 1 power place. And then again, we look at this quotient and see, can we divide this by 8 and still get a whole number with a remainder, right? Is this bigger than or equal to 8? Can we divide it? Well, in this case, no, 1 is less than 8. We can't divide 1 by 8 and get anything besides a fraction. There's no whole number part. So this 1, because we cannot divide it by 8, it's not bigger than or equal to, this becomes our 8 squared place. And so now we can use this to write this out in an expanded form. So I think it's really helpful to write this in an expanded form before you write it in the base, before you just write it as this number, base 8. I think it's really helpful. So we have that 93 is, we're going to work backwards here. So it's 1 times 8 squared plus 3 times 8 plus 5 times 1, right? This is just like the expanded form that we wrote in the last video. And so we can have that 93, and see, I like writing it in this expanded form because we can go back and verify this, right? We can work out 1 times 8 squared, 3 times 8, and 5 times 1 and add them up and verify that these do in fact have the same value. And then we can write 93 is 135 base 8 And remember, you can write it either way with an 8 in your subscript or the word 8 in your subscript. Okay, I'm just gonna box this answer right here, just so we see it more clearly, and I'm gonna actually go back and box these answers. Go back and box these. Okay, and then this one up here. Yeah, you may have your students box their answers on any written work just so it's more clear what's the answer and what's the work, so you can see the thought process more clearly. Here, this page is a little bit busy, so I just feel the need to do that. Okay, so next we're doing 642 base 5. So just like up here in our base 8 example, the first thing we do is take 642 and divide by 5. So 5 goes into 6 one time. We subtract and get 14. It goes into 5 two times. We subtract 10 and get 42, which goes into 5. 5 goes into 42 8 times, which leaves us with a remainder of 2. So just like before, this 2 is going to represent our ones value. So now we have 128 as our quotient. So since that is bigger than or equal to 5, we can divide it by 5. So now 128 divided by 5, 5 goes into 12 twice. Subtract 10 and you get 2, bring down the 8, you get 28. So 5 goes into 28 5 times. 5 goes into 28 5 times, and we have a new remainder of 3. So we have 3, whoops, it's not in our tens place. This is in our fives place. Okay, so again, here we have 25, which is greater than or equal to 5, so we can divide it one more time. So we do 25 divided by 5. Well, since we know that 5 times 5 is 25, so we get a remainder of 0 here that goes in our 5 squareds place. Again, this quotient is 5, which means that it is greater than or equal to 5, right? It satisfies that equal to. So we can divide it one more time. 5 goes into 5 one time with a remainder of 0. So just like before, that remainder of 0 gives us our 5 cubed place. And this final quotient, when we finally get a quotient that is strictly less than 5, this becomes our last place. So 5 to the 4th place. So I don't have room to write it out here in expanded form, but again, I highly recommend writing this out in expanded form just to verify that you did all of your operations correctly and that this does in fact add up to 642. So we can put it together now, saying that 642 base 5, again, we work backwards here. So we have 1 in the largest place, then 0, 0, 3, 2, and this is base 5. So 642, sorry, that base did not go there. 642 base 10, which we can go ahead and write this as a 10, just to be very clear that it is in base 10, is equal to 10032 base 5. Okay. So now, since we've done these examples, I just want us to think about how would we explain this. So obviously, I know how I would explain it because I just explained this to you in this video. But whenever you're thinking about how to explain things to your students, it's best to have it written down and think about how would you explain this to someone who's never done it before. So I encourage you to pause this video at this time, to pause and see how would you describe it? And then we'll go through it in a minute. Okay, so first, what process is used to convert to base 10? So this is the examples that we did, not this video, but the last video. So remember, the first thing that we did when we converted to base 10 was write the number in expanded form. Right, so we wrote the number in expanded form for whatever base it was in, And then once we had it in expanded form, all we had to do was evaluate the expression. And that is what gave us the base 10 number. So we evaluated the expression to get base 10. And so remember, we just use the base 10 operations. We carry once we get a 10, and that was how we get to base 10. So now, how do we convert from base 10? So the examples we did on this page, if we have something in base 10, how do we get it to a new base? So remember, the first thing that we did was divide the number that we're looking at by the new base. So right here in this base 5 example, we started by dividing 642 by 5. So now we record the remainder as the ones value. So that remainder goes in as the value in the 5 to the 0, which is the ones place. So once we recorded that remainder, then we looked at our quotient, and we said that if the quotient was greater than, or equal to 5, sorry, I'm having a hard time writing this 5. Greater than or equal to 5, not 5, the base. Greater than or equal to the base, then we divide by that base again. And we just keep repeating this process, right? Just like we did in that example for 642, we repeat the process. Repeat until what? Until we have that 1 as our quotient, which meant we couldn't divide by 5 anymore. So repeat until the quotient is less than 5, because once it's strictly less than 5, or the base, then we can't divide anymore. So we repeat until the quotient is less than the base. And then what do we do with that quotient? So then we record the quotient as the next smallest in the next smallest place. So see what we did up here, doing base 5, we recorded that 1, the next smallest place, because we had already recorded our remainders for the 1's place, the 5's place, the 5 squareds, the 5 cubes place, so we had to record our quotient in the 5 to the 4th place, because that was the next smallest, and then we're done. Okay, so this is the process to convert to and from base 10. And that's it. So bases are a little bit complicated when you're just trying to get used to them, but I encourage you to practice. You can even make up examples on your own, but definitely practice with this. I think the more that you practice with different base systems and doing operations in different systems, the easier it is. But I just want to highlight why we're doing this. So we're doing this in this class because you all know how to add, subtract, multiply, divide really easily. We've been doing that our whole lives, right? And we choose to teach this class using numbers in different bases to just kind of remind you the difficulty in learning how to add, subtract, multiply, divide when it's difficult in these different bases because it's something you're not used to. So we talk about these bases to just kind of remind you what it's like to learn how to do these basic operations again. But that is all for chapter 2. So that's all for section 2.2 and 2.3. That's all for chapter 2. And so that is all for this video.